Tyrannosaurus rex is one of the most impressive predators the planet Earth has ever seen in its 4.5 billion year history. This immense carnivore was perfectly adapted for bone-crushing bites, aided by its strong senses to detect its prey, and would undoubtedly have struck fear in the many prehistoric species it lived alongside. Indeed, even in death, the bones of this fearsome dinosaur continue to terrify and inspire people worldwide. But given how iconic this dinosaur is, it's bound to be involved in a few controversies. In fact, that's a bit of an understatement. Besides everyone's favourite problem child, Spinosaurus, it's hard to think of a dinosaur species that has been argued over more than Tyrannosaurus rex. Paleontologists, the scientists who study prehistoric life, really do love a good disagreement, and T-Rex has provided ample opportunity. One of the most enduring controversies, and definitely one of the most intriguing, is the issue of Nanotyrannus. Nanotyrannus lancensis was the name given to a skull of a tyrannosaur found in Montana. This skull was small, only about 2 feet long, and when paleontologists examined it in 1988, they became confident that it represented an as yet unrecognized species of dwarf tyrannosaur, one that would have coexisted with Tyrannosaurus rex in North America at the very end of the age of the dinosaurs. But of course, as this is paleontology, since then there has been a great deal of debate over the validity of the dwarf tyrannosaur, with other scientists finding that there's no such thing as Nanotyrannus, and that the fossils associated with this name are actually just juvenile T-Rex. So I thought it would be fun to delve into this disagreement and examine the history of the debate, along with all the evidence both supporting and opposing the existence of Nanotyrannus. And speaking of juvenile T-Rex, I'm very pleased to say that this video is brought to you by Jurassic World Evolution 3. Releasing on PC, PS5 and Xbox Series S and X on October 21st, the third installment in the Jurassic World Evolution series now features juvenile dinosaurs. In this game, you'll be able to create and manage your own parks, customize them however you like, and you can play the campaign, challenge mode, or just play about in the sandbox mode. It's going to have some really cool new locations too, such as Japan and Hawaii, and the terrain tools look absolutely fantastic. The game also features characters from the films, including Dr. Ian Malcolm, voiced by Jeff Goldblum himself. More than 70 different prehistoric species will be included, and the juvenile dinosaurs all look adorable. It's no secret that I am a massive fan of Jurassic Park. It's one of the things that solidified my love for paleontology, and I have many hours sunk into Jurassic World Evolution, so I'm very excited for the third installment. Be sure to click the link in the description below to pre-order the game. Now, heading back to 1988 when Nanotyrannus was first named, this paper was authored by a team of paleontologists led by Robert T. Bakker, a legendary figure in the history of dinosaur research who was largely responsible for transforming the public perception of dinosaurs from slow, stupid reptiles to active and successful creatures, a period of time known as the Dinosaur Renaissance. Funnily enough, he also has a Jurassic Park connection. He's mentioned by name in the first film by Timmy, and the character of Robert Burke in The Lost World was also very clearly based on him. Bakker and his colleagues argued that the skull, which was housed in the Cleveland Museum of Natural History, was a distinct species from T-Rex for several reasons. Firstly, although the skull had been unearthed from the Hell Creek Formation, the home of T-Rex, they argued that it was unique compared to all other known tyrannosaurs for having a very narrow snout, an extraordinarily wide back of the skull, and lacking distinct ridges along the bones of the top of its muzzle. They also found that it shared some features with a species of tyrannosaur called Alioramus, a lightly built, long-snouted form known from Asia. Not only did the long and low snout look a bit like Alioramus, but the teeth in the maxilla, one of the upper jawbones, were also very narrow from side to side, another feature of Alioramus. The number of teeth in the Cleveland skull was, and still is, a point of discussion too. This skull has 15 teeth in the maxillary bones and 4 in the premaxillary bones. Known specimens of adult T-Rex all have 4 premaxillary teeth. However, the maxillary tooth count varies, with an average of 12 teeth in adult T-Rex. So the Cleveland skull has more teeth than an average adult T-Rex, which was used as more support for this being something distinct. Another of their key arguments for a separate species was that they interpreted the skull as being from a fully grown animal, not a juvenile. The reason for this is that they said many of the skull bones were fused together, something that in many animals indicates maturity. As an animal gets older, the sutures in the skull that were open when it was younger will join together more securely. So according to the 1988 paper by Bakker and others, the Cleveland skull was from an animal that had reached adulthood, and so it could not possibly be from a young T-Rex. The paleontologists therefore presented their concept of this newly recognized dwarf tyrannosaur. Nanotyrannus must have been a swift, medium-sized predator with incredibly acute stereoscopic vision owing to its forward-facing eyes, and was probably not a bone cruncher like T-Rex. Instead, its narrow jaws and slender teeth suggested it was better at slicing flesh from its chosen prey. So here they had an idea of two coexisting tyrannosaurs that were adapted to feed in different styles, allowing them to coexist in the terminal age of the dinosaurs. The problem with many of these conclusions about the Cleveland skull, though, is that they're not actually based on sound evidence. It didn't take long for other paleontologists to criticize many of the interpretations made about Nanotyrannus, with one publication in 1992 raising several concerns about the idea of Nanotyrannus and highlighting the variability of bone fusion in dinosaurs, suggesting this might not be as conclusive proof of the Cleveland skull being an adult as previously thought. Then, in 1999, Tyrannosaur specialist Thomas Carr published a detailed analysis of the Cleveland skull, concluding it was almost certainly just a young Tyrannosaurus rex. The Nanotyrannus Wars had officially begun. This 1999 paper used known specimens of the Canadian Tyrannosaur Gorgosaurus, which is represented by fossils of several different growth stages, and constructed a hypothetical trajectory of how this dinosaur's skull would have changed as it got older. Then, comparing the changes in Gorgosaurus to the Cleveland skull, Carr found that many of the features in the apparent Nanotyrannus skull were actually very consistent with what was seen in the immature stages of Gorgosaurus. First of all, one of the most significant claims about the Cleveland skull suggesting it belonged to a different species was the idea that the sutures were fused. In reality, the skull sutures are not fused, they're still open. I'm not sure how exactly that mistake was made. It might have been because the skull was heavily restored in plaster, and the 1988 paper seems to have potentially carried this mistake over from an even older study that claimed there was fusion of bones. But yeah, the claim that there's fusion in the skull is just completely untrue, and you'd think that would be something the authors checked. In fact, according to the 1999 study, apart from one, none of the specific bone fusions discussed in the Nanotyrannus paper occur externally in any known tyrannosaurid skulls at any growth stage anyway. Another major blow for Nanotyrannus resulting from the 1999 study was the finding that the texture of the Cleveland skull bone is very much consistent with the immature bone texture in Gorgosaurus, indicating that the bone had not finished growing and developing. Additionally, looking at how the shape of the Gorgosaurus skull changed as it aged, it was found that a transformation from the anatomy of the Cleveland skull, which has quite a narrow snout with thin teeth, to the skull of an adult T-Rex, which is much more robust and with wider teeth, is actually very plausible for these animals and would be expected to occur. This was especially supported by the fact that the Cleveland skull shared many characteristics with adult T-Rex skulls, characteristics that are unique to T-Rex and the Cleveland specimen. As for the difference in the number of maxillary teeth between adult T-Rex and the Cleveland skull, it was argued that a loss of teeth as tyrannosaurs age is actually typical for the dinosaurs. Again, looking at the Gorgosaurus growth stages, the 1999 Carr paper reports how younger Gorgosaurus had up to 15 tooth sockets in the maxillary bones, whereas the older specimens had 13 or 14. So having more teeth as a juvenile is again an expected feature in T-Rex, and that's exactly what the Cleveland skull shows. Carr also said that tooth loss during the aging process is not even unique to tyrannosaurs, and has been reported in some modern crocodile species as well as the false gharial. The early 2000s saw further criticisms of the Nanotyrannus hypothesis, including some papers that mentioned how the slender teeth in the Cleveland skull, which had been used as another way to distinguish it from adult T-Rex, is also not a compelling argument for Nanotyrannus validity. Some of the maxillary teeth had actually been restored in plaster, and researchers also noted that the teeth at the back of the upper jaws are in fact relatively slender in all tyrannosaurids, as their teeth tend to become flatter at the back. So it's argued the teeth of the Cleveland skull are again not that unusual compared to an adult Tyrannosaurus. But in 2002, another major development in the research history of Nanotyrannus occurred when a Tyrannosaur specimen known as Jane was excavated in southern Montana, also from the Hell Creek Formation. Supporters of Nanotyrannus validity claimed that Jane, although it is yet to be fully described in detail, indicates that Nanotyrannus is indeed a real separate organism from T-Rex. Jane preserves a partial skull and skeleton of a small tyrannosaur, approximately 6.5 meters in length, or about 21 feet. This is obviously much smaller than a fully grown T-Rex, but Jane also has some fused bones in its skeleton, including a fused pelvis, fused bones of the pectoral girdle, and some fused backbones, features that Nanotyrannus proponents cite as evidence that Jane was nearly fully grown. This is despite the small size, and Jane has fused bones that are not even fused in many fully grown T-Rex specimens. Additionally, Jane also has more teeth in the maxillary bones than adult T-Rex do, as well as many more teeth in the lower jaws, called the dentaries. Now, although the use of tooth counts to establish Nanotyrannus as distinct had been refuted in that 1999 study, other paleontologists fired back at these conclusions. A paper published in 2003 by Philip Curry, who was also involved in the original 1988 Nanotyrannus study, challenged the arguments presented in the Gorgosaurus growth stage paper. Curry explained that the growth series might not have been entirely accurate, as the differences in size and proportions among the tyrannosaur specimens used to establish the way these dinosaurs aged might have been more related to differences between species of different sizes, rather than related to the growth stage, as they were looking at comparing Gorgosaurus, Daspletosaurus, and T-Rex to evaluate growth stages. Therefore, he did not believe the comparisons were sufficiently effective to establish growth stages in tyrannosaurs. He also stated that many of the features claimed to be present only in the Cleveland skull and T-Rex could actually be seen in other tyrannosaurid species too. This 2003 paper also disputed the argument that tyrannosaurs underwent tooth reduction as they grew. They examined maxillary tooth counts in Gorgosaurus, the Asian Tarbosaurus, T-Rex, and the Cleveland skull, and compared these counts to the skull sizes of the specimens. Rather than detecting a tendency for tooth counts to decrease in larger Gorgosaurus specimens, they actually found the opposite. Some of the larger skulls actually had more teeth in them than the smaller ones. A similar trend was seen in Tarbosaurus, but then Tyrannosaurus itself showed a slight trend towards decreasing tooth count with skull size. However, overall, the results of this analysis proved not to be significant enough to determine any real meaning, other than showing that there wasn't really a notable decrease in tooth count with age in Gorgosaurus, as the 1999 paper had concluded. But then Thomas Carr responded once more in 2004. Together with another colleague, he created a growth series for Tyrannosaurus rex by arranging 5 known specimens in order from youngest to oldest. According to this interpretation, the Cleveland skull was the second youngest in the series, while a fossil called the Jordan theropod at the Los Angeles County Museum was the youngest T-Rex. Another specimen at the LA Museum, a subadult T-Rex, was slightly older than the Cleveland individual. So it looks like a pretty complete growth series for the dinosaur had been established. Although there was a significant transformation in skull shape from younger to older Tyrannosauruses, this study found these to be very plausible modifications to the skull anatomy. In 2005, paleontologists organised a conference dedicated to the latest tyrannosaur research, which took place in September in Rockford, Illinois. The motivation for holding this conference was actually driven by the recent discovery of Jane and the controversy surrounding this specimen regarding what it meant for Nanotyrannus. From this conference, and the resulting book that collected much of the research presented here, another detailed argument in favour of Nanotyrannus being real was published, this time by Tyrannosaur specialist Peter Larson, founder of the Black Hills Institute in South Dakota. Larson claims that Jane is clearly referable to Nanotyrannus on account of those fused bones we mentioned earlier, and also because of where this individual sits on estimated Tyrannosaur growth curves. Jane had, at this point, been estimated to have died when they were about 12 years old, which, when placed onto curves of Tyrannosaur growth, would mean Jane was a little small for a T-Rex of this age. Larson noted that various other features of Jane's skeleton differed from T-Rex, such as a hook-like bone expansion on the pelvis that T-Rex lacks, unusual anatomy of the scapula where the arm attaches, differences in some skull bone openings, and other traits. The publication also once again challenged the idea that tyrannosaurs definitely lost maxillary teeth as they aged, and even countered the claim that tooth loss can be observed in some modern crocodilians, explaining that the reports cited by Carr's 1999 study were misunderstood. They did not discuss crocs losing teeth with age, but rather examined how skull proportions change over time. Larson also examined teeth from modern American alligators to support this, finding some individual variation but no consistent pattern. Therefore, although tooth count may have varied among tyrannosaurs, Larson concluded there was no evidence that their tooth count changed significantly with age, and therefore the higher counts in Jane and the Cleveland skull were still quite unusual. Larson also highlighted differences in the skeletons of Jane and other T-Rex specimens related to the dinosaurs' respiratory systems. The bones of theropod dinosaurs became invaded by the air sac complexes that these dinosaurs used for breathing, and so openings in the bones can be utilised to study these systems. Jane's skeleton was reported to include a number of differences in the sizes and shapes of the bone openings, which Larson again used to suggest a separation from T-Rex. So lots of interesting arguments have been made both in favour and in opposition of recognising Nanotyrannus as a distinct species from T-Rex. But at this point, generally most paleontologists were leaning towards Nanotyrannus being invalid. Still, one of the most intensely argued over aspects of this whole debate remains the question of tooth count, and whether it really did decrease in tyrannosaurs with age. Another paper published in 2011 added some more data to this particular discussion when a juvenile Tarbosaurus bata skull from Mongolia was described. This species, which lived in Asia at the very end of the Cretaceous period, was a very close relative of T-Rex, and so information about Tarbosaurus growth changes is very relevant to the Nanotyrannus debate. The little Tarbosaurus skull was found to have come from a very young individual, but when looking at the tooth count of the specimen, it was found to have the same number of teeth in both the maxilla and the dentary as adult Tarbosaurus specimens. This again adds more evidence arguing against a tooth reduction in growing tyrannosaurs being typical and expected for the lineage. Still, as the paper notes, it is possible that some degree of individual variation is still at play in T-Rex, or indeed it could be that T-Rex was unique among tyrannosaurs in undergoing this dramatic change in tooth count. Around this time though, it seemed as though there was a bit of a stalemate in the debate. Most paleontologists still considered the simplest explanation to be that Nanotyrannus was T-Rex, but those who were convinced of its validity weren't really shifting anytime soon. But then, rumours about the discovery of another specimen that could settle the debate once and for all began to really heat things up. In the summer of 2006, one of the most extraordinary fossils in the history of paleontology was uncovered in Montana. A Triceratops pelvis was found weathering out of a hillside, and after several months of digging, fossil hunters revealed that there was a complete skeleton of the ceratopsian here. But it wasn't just a Triceratops. Intertwined with the herbivore's skeleton was a practically complete body of a tyrannosaur. The dueling dinosaurs had apparently been locked in a fight to the death, when they must have been swiftly buried by sediment more than 66 million years ago and preserved together in this extraordinary fashion. However, because the fossils were found on private land, things got complicated with these skeletons, and they were held privately for over a decade while attempts were made to sell the specimen. It wasn't until 2020 that the fossil was, very fortunately, acquired by the North Carolina Museum of Natural Sciences, where it is now on display to the public, and a proper scientific analysis of the unbelievable fossil is underway. So what's this got to do with Nanotyrannus? Well, back in 2013, Pete Larson again stirred things up when he presented a poster about this tyrannosaur fossil at a conference of the Society of Vertebrate Paleontology. Larson nicknamed this particular individual Bloody Mary, and although at the time it was still in private hands and therefore couldn't be officially verified by other paleontologists, he claimed it was another specimen that proved Nanotyrannus was a valid species. The main new argument concerning the Bloody Mary specimen relates to the animal's forelimbs. Although this specimen is relatively small, its arms and hands are notably large both proportionally and in absolute size. Comparing Mary's arm to that of a fully grown T-Rex reveals an intriguing difference, making it a rather compelling piece of evidence. However, at the time, because the dueling dinosaurs were private specimens and inaccessible to most researchers, many paleontologists dismissed these findings. But now that these animals are housed in a museum and are being studied, it hopefully won't be long before the proper scientific study is published on Mary, and I am very, very interested in what conclusions will be drawn about Nanotyrannus from this specimen. Personally, in my opinion, this does appear to be some of the strongest evidence for its validity so far, but I will wait to see what the detailed study of this fossil uncovers before I jump to any conclusions. The specimen is also particularly incredible for just how intact both skeletons are, with the Tyrannosaur apparently being more than 98% complete, and also preserving some impressions of soft tissues. So in the context of these rumours about Bloody Mary floating around the paleontological community, we move on to 2016, another quite eventful year for Nanotyrannus. Phil Curry, one of the original members of Team Nano, published another paper with a colleague concluding that the dwarf Tyrannosaur was real. This time, they examined the lengths of the hind limbs of various carnivorous dinosaurs, focusing on how the length of the leg bones relates to running speeds. They took measurements from Jane and Mary and compared them to other tyrannosaurs, discovering that they had proportions unlike any other known tyrannosaur with legs well suited for a fast-running lifestyle. However, they do also clarify that the specimens they consider to be juvenile T-Rex have limb proportions suited for running as well. So it does just seem to be that younger T-Rex were very fast animals capable of chasing down speedy prey. So not the best case for Nanotyrannus being distinct, to be honest, as it doesn't really prove that this aspect of the specimens was completely different from young Tyrannosaurus. Another academic skirmish took place later in 2016 when a paper supporting the validity of Nanotyrannus was published by a couple of other researchers who looked at the anatomy of the lower jaw bones of theropod dinosaurs, the dentary bones. They claimed to identify a distinct groove running along the outside of the dentary in some species, while others did not have this groove, and they argued that this feature could be useful in determining relationships between specimens. Since Jane was said to possess a groove, but apparently no adult T-Rex specimens do, they concluded this was another point in favour of Nanotyrannus' distinctiveness. But it wasn't long before another group of paleontologists responded to this publication by arguing that the significance of the dentary groove is overstated, as many other tyrannosaurs, including T-Rex itself, also possess this feature. It turns out that this is another anatomical trait that can change quite a bit as the animals grow, and although it's a very deep, sharply bordered groove in juvenile tyrannosaurs, it's still there in adults, it just becomes much shallower. So once again, another dead end for proving Nanotyrannus, it seems, as this feature cannot be used to clarify its validity. The next major developments in the world of Nanotyrannus research took place in 2020. Not only was this the year when a museum finally acquired the Dueling Dinosaurs, but two significant studies were also published, both of which delivered more blows to the case of Nanotyrannus. The first was a detailed new analysis that revisited the older arguments about the growth rates of Tyrannosaurus and the specimens assigned to Nanotyrannus. This study took thin sections from the limb bones of Jane and another more fragmentary small tyrannosaur. These thin sections displayed growth rings, similar to tree rings, that could be counted to establish how many years the tyrannosaurs had lived before they died. They revealed that Jane was at least 13 years old at the time of death, and their other specimen was at least 15. Very significantly, the outermost layer of bone in the thin sections was also clearly still in the process of being deposited and remodeled, meaning that Jane and this other specimen were not fully grown when they died. They were skeletally immature individuals. So according to this interpretation, Jane is most likely a juvenile Tyrannosaurus rex that had not yet begun the rapid growth spurt that T-Rex experienced during its teenage years in order to achieve its robust adult form. An alternative idea that the study does consider, however, is that perhaps Nanotyrannus could still be a real organism, but that Jane would then represent an immature Nanotyrannus. In any case, there's no denying that Jane was still growing at the time of death. And the simpler explanation, the one favoured by the researchers, is that this is a juvenile T-Rex. The second paper published in 2020 was another publication by Thomas Carr, again focusing on growth rates. In this study, he assembled a comprehensive dataset using 44 specimens to build an ontogram of Tyrannosaurus, that is, a branching diagram showing how T-Rex changed with age. So basically, a much more detailed version of his older 2004 study. 21 growth stages were recognised, and it was revealed that the most dramatic changes to the skull shape, going from shallow to deep skulls, would have happened somewhere between 13 and 15 years of age. T-Rex also outgrew its immediate relatives between the ages of 15 and 18 and probably reached sexual maturity before 15. The study documents the precise transformations the T-Rex skull undergoes as it ages, finding that these changes can indeed occur quite rapidly over a 2-year period. So this dramatic change is essentially a secondary metamorphosis. It also shows that there is a lot of individual variation among T-Rex, and again touches on the tooth count issue, finding that the number of teeth actually initially increases from the youngest individuals to the subadults, before decreasing again in the older growth stages. This would mean that Jane and the Cleveland skull, being young teenagers, were at the peak of increased tooth number. The study does also find that individual variation still influences the tooth count of fully grown rexes, so among adult T-Rex specimens, tooth count cannot be used as a reliable proxy for determining age. This paper also looks at changes in the air sac systems of T-Rex as they grow, another aspect that had been used to support Nanotyrannus, and finds that, once again, these undergo traceable changes throughout the growth series, and that there's a lot of individual variation in these traits. Therefore, it is another study that again casts significant doubt on many of the features in Jane and the Cleveland skull used to argue for the distinctiveness of this dwarf tyrant, as it identifies various similarities between these specimens and those of Tyrannosaurus individuals of various other ages, including characteristics not present in any other tyrannosaurs. Then we flash forward to the start of 2024, when 2 more paleontologists published an extensive new paper arguing in favour of recognising Nanotyrannus. This research essentially summarises all the previous main points that had been looked at when considering the Tyrannosaur's validity, and also takes into consideration the broader aspects of Tyrannosaur ecology and the diversity of these carnivores in the Cretaceous world. The argument from an ecological and diversity perspective emphasises that, towards the end of the late Cretaceous period, there was generally a high diversity of predators in dinosaur-dominated terrestrial ecosystems and in marine ecosystems at that time. Therefore, these paleontologists argue that we should expect there to have been multiple tyrannosaur species in latest Cretaceous North America, and that, in fact, the more unusual situation would have been that only T-Rex lived there. They also disagree with the interpretation that the specimens assigned to Nanotyrannus fit neatly into a Tyrannosaurus growth series, arguing that no clear intermediate forms between these tyrannosaurs actually exist, and that analysing the anatomy of these specimens groups them into a distinct Nanotyrannus versus a T-Rex cluster, instead of a continuum from one to the other. They additionally point out that for the transformation of the Nanotyrannus type to the adult T-Rex form, this species would have to undergo a growth series unlike any other known tyrannosaur, again citing the discovery that young Tarbosaurus are rather more similar to their adults. This paper goes over the growth rates of these dinosaurs as well, arguing that although Jane and the other specimen analysed in that 2020 paper were not done growing, they were slowing down their growth, and therefore were young adults approaching their maximum body size when they died, and would not have been capable of following a growth curve that meant they eventually ended up at T-Rex dimensions. They also cite a tiny fragment of skull bone, a bone called a frontal, uncovered from Hell Creek, that they say comes from a tyrannosaur smaller than the Cleveland skull, but which shows features shared with adult T-Rex, features that are not shared with the specimens assigned to Nanotyrannus. So, they argue, this small bone represents a true juvenile T-Rex, whereas Jane and the others must be a separate smaller species. Finally, they also perform an analysis of the evolutionary relationships of tyrannosaurs to each other, and find that the specimens associated with Nanotyrannus group far away from Tyrannosaurus itself, instead being closer to the Alioramines, Albertosaurus, and Gorgosaurus. Therefore, taking all of this together, they say that the best explanation has to be that Nanotyrannus is not the same thing as juvenile T-Rex. This paper has seen some pushback from paleontologists online, especially with regards to the very fragmentary frontal bone being used as evidence for Nanotyrannus when it's so incomplete. And the ecological arguments are generally not seen as convincing, since Hell Creek appears to have been an unusual ecosystem anyway that was unlike many of the slightly older formations containing multiple tyrannosaur species. However, the growth curve data presented in the paper is generally considered pretty intriguing, and a valuable aspect of the argument. The detailed documentation and summary of all the noted differences between specimens called Nanotyrannus and those of adult T-Rex was also appreciated. One of the latest contributions to the Nanotyrannus debate was mentioned in a paper published in June 2025, describing a new species of Tyrannosauroid from Mongolia, Carnculu mongoliensis. The authors of this study write how, during the course of their research on tyrannosaurs when describing this new species, they examined CT scans of the jaws of the T-Rex specimen known as Su, and noticed something that had not been reported before. They saw that the remains of a resorbed tooth socket is present at the very back of the left maxillary tooth row, providing direct evidence that Tyrannosaurus indeed reduced the number of teeth in its jaws as it grew, as, clearly, Su would have once had more teeth in the upper jaw than it did when it died. This study also commented on the 2024 paper that found Nanotyrannus to group with tyrannosaurs away from T-Rex on the evolutionary tree, stating that they were probably including characteristics related to the skeleton's immature state, which skewed the results of the analysis. That pretty much brings us up to date with the current state of Nanotyrannus research. This really is a fascinating topic of discussion, and it's quite remarkable that it still hasn't been settled once and for all, nearly 40 years after the debate was sparked. So, if Nanotyrannus does one day end up being proven to be a real species, what would this mean for tyrannosaur science? Well, it would indicate that tyrannosaur diversity, especially in North America, could have been underestimated, as the final stage of the Cretaceous would not only have been home to T-Rex, but also the dwarf forms that occupied the mesopredator niche and presumably hunted in a very different fashion, running quickly after prey and using their rather more compressed teeth to strip flesh, instead of crunch through meat and bone like T-Rex. There are interesting discussions to be had here about how Nanotyrannus would then have presumably competed with actual juvenile Tyrannosaurus for prey, as they both would have been medium-sized, relatively slender predators and therefore might have faced pressures from one another as they hunted the same animals. Depending on where Nanotyrannus falls among the Tyrannosaur evolutionary tree too, it has some fascinating implications for the evolution of the tyrant reptiles, perhaps indicating that some more basal lineages lived on in North America until the very end of the age of dinosaurs. And if it's not valid, and all the specimens associated with Nanotyrannus really are juvenile T-Rex, then we know a great deal about Tyrannosaurus growth stages. Going by this interpretation, which, to be clear, is currently the majority opinion among paleontologists, this means that T-Rex underwent an incredible shift in anatomy and subsequently diet as they aged. Not only would T-Rex have occupied the apex predator niche in the Hell Creek ecosystem, but the youngsters of this species would have been specialized in such a way that they themselves filled the roles of middle-level theropod predators. The delayed growth spurt in T-Rex compared to other tyrannosaurs is a fascinating adaptation that enabled these dinosaurs to be effective predators of smaller-bodied prey items until they reached about 15 years old. And then, in the course of a couple of years, they exponentially grew in size to become predators of much bigger dinosaurs. Juvenile rexes would not have been capable of crunching through bone and consuming it like adults did. However, there is evidence that they could puncture bones. Evidence from a hadrosaur's tailbone, that is, one of the so-called duck-billed dinosaurs, was found showing traces of bite marks inflicted by a late-stage juvenile T-Rex. It therefore seems that once rexes reached about 12 to 15 years of age, they actually began tackling some of the large dinosaurs in Hell Creek, mirroring what adult T-Rex were hunting. However, they were still using a different style of predation, as their bite forces were not yet as colossal as adults. But, very interestingly, they were still managing to drive their more narrow, blade-like teeth into the bones of their prey. So this could be direct evidence of the transition of Tyrannosaurus from its younger hunting tactics to those it would adopt as a fully grown animal. We've also found evidence that young rexes may have engaged in play fighting with each other. Looking at Jane's skull, there are some healed bite marks along the top of the snout that seem to have been inflicted by a theropod of a similar size. This has been taken to suggest that, assuming Jane was a juvenile T-Rex, these young animals would often bite each other's faces. As juveniles, this biting probably wouldn't have been related to courtship displays, but perhaps it was brought about by conflicts over territory or dominance, or possibly even play behaviour that helped these young animals practice such behaviours for more serious clashes as adults. Unfortunately, there is no direct evidence about how juvenile T-Rex might have interacted with their parents or other adults, but it's plausible that Tyrannosaurus cared for its young and tended to its nests, since this behaviour is common among modern birds and crocodilians, the two living lineages of animals that are closest to non-bird dinosaurs. However, the evidence showing juveniles and adults focusing on different prey suggests that, at least during the later juvenile stages, they probably hunted separately and stayed out of each other's way. In summary, according to the fossil evidence we have, and assuming Nanotyrannus is really invalid, young Rexes were slender, agile little hunters that would potentially play fight with each other, and during their youngest stages may have been cared for by their parents. Which brings us to one of the most exciting aspects of Jurassic World Evolution 3, the sponsor for this episode. In the new game, juvenile dinosaurs have now been added. Now, to be clear, the game does not feature Nanotyrannus, and so these are most definitely juvenile Rexes. And as you can see, they're pretty lanky little things with long legs, narrow skulls, and faster movements than the adults. I love the designs they've gone for here, as they represent the overall proportions of real juvenile T-Rexes, while also paying homage to the design of the baby Rex in the Lost World, and looking consistent within the Jurassic World universe. So what are you waiting for? Be sure to click the link in the description below to pre-order Jurassic World Evolution 3, releasing October 21st on PC, Xbox Series S and X, and PS5. And get ready to look after your very own juvenile Rexes. Thank you so much for sponsoring this video, it really is very exciting to be sponsored by a game I was already so hyped for. So, some final quick thoughts that I have personally on the whole Nanotyrannus debate. Whatever angle you look at it, it's incredibly intriguing to think that either there was a dwarf tyrannosaur coexisting with T-Rex, or that T-Rex changed so dramatically as it aged that it occupied several very different niches throughout its lifetime. I don't think the tooth count argument is particularly solid for Nanotyrannus, since it's so variable in T-Rex anyway. However, it is certainly notable that Jane and the Cleveland skull have the most of any known specimen, but that could just be down to some strange quirk of the sampling, as we're really only working from very few individuals, and maybe these youngsters just happen to have more than the average Rex. So that doesn't particularly convince me. The argument that Nanotyrannus must be real because otherwise T-Rex grew so unusually compared to other tyrannosaurs is also not something that I find particularly compelling, since, yeah, T-Rex is a very unusual and extreme dinosaur, even among tyrannosaurs. The niche partitioning and ecology debate is also rather self-enforcing, either way you look at it. Either there was a dwarf tyrannosaur filling in the mesopredator role in Hell Creek, one that presumably competed with young T-Rex for similar food sources, or young T-Rex filled in this niche, before they then rapidly grew and transformed into their adult morphs, which were specialised differently. In both cases, you've got something filling that niche, so I don't think saying that it's unusual that there's no theropod mesopredator in Hell Creek is a good argument for Nanotyrannus either. I do also think that many of the differences in anatomy identified between Nanotyrannus specimens and adult T-Rex can quite plausibly be explained by age-related differences or individual variability. Though the fact that there are quite so many distinct features, some of which are only shared between Nanotyrannus specimens and more basal tyrannosaurs, is definitely interesting and needs to be addressed further. The growth rate arguments, I think, are probably some of the most solid arguments in favour of Nanotyrannus being distinct. The finding by the 2024 paper that the bone cross-section rings of Jane, which are used to estimate age at death, don't match a predicted T-Rex growth curve needs further exploration, as according to these results, it does look like Jane was slowing in growth, not about to accelerate. But really, the only way to fully solve this issue is to find a juvenile T-Rex of the same size and therefore age range as Jane and the Cleveland skull that is distinctly different from these specimens and shows more similarities to adult T-Rex. In that case, we could fairly confidently say that Nanotyrannus is something separate. However, if we continue to find more tyrannosaurs the size of Jane and company that all look quite like them, then that doesn't really clear things up. But it would likely add further support to the idea that that's simply just what juvenile T-Rex looked like. I'm very hopeful that the analysis of the Dueling Dinosaurs can reveal some much needed new insight into this fascinating controversy, so I'm very excited to see what's found there. I'm honestly open to both sides of the argument, and wherever the evidence leads is where I intend to follow. For now, I think there's not quite enough convincing evidence to sway me towards accepting Nanotyrannus as real, and I still think the simplest explanation is that they're juvenile T-Rex, especially since it's a bit suspicious that we otherwise wouldn't have found any Rexes of this growth stage yet. But I'm very happy to be proven wrong, and depending on what we find next, I could easily change my conclusions about this. I hope you enjoyed this wild ride as we explored this intense debate, and please do let me know in the comments your thoughts on the whole discussion. I'm so excited to see what happens next. Thanks again to Frontier Developments and the whole Jurassic World Evolution 3 team for sponsoring this video, and for allowing me to make this video exploring the Nanotyrannus debate. It's something I've been wanting to cover for a long time. Please do like this video and subscribe to the channel if you enjoyed it, and be sure to press that bell icon so you don't miss our next upload, and so you can learn more about our world, its history, and the wonderful life that surrounds us all.